Hey folks, we're helping PBS celebrate the Great American Read. We sat down with Sam Kean to talk about his book, Caesar's Last Breath, and how the chemistry of atmospheric gases can be so darn interesting. The book explores the classic chemistry question. Are you breathing some of the same air molecules that were expelled by Julius Caesar's dying exhalation? It's something you simply can't work out exactly without knowing a ton of data. Caesar's exact lung capacity, the composition of the air in ancient Rome, atmospheric circulation from March 15th, 44 BCE to the present day, and... No, stop. I'm getting a headache. Instead, you treat it as what we call a Fermi problem. Physicist Enrico Fermi had a knack for working out rough estimates that weren't actually right, but were close enough to give you the general idea. Using Fermi's close enough style of logic, what do you get? Are we breathing Caesar's last breath?
So yes, we are actually breathing parts of Caesar's last breath. Each person, when you breathe, it's about a half a liter to a liter. In the book, I mentioned how much it is, but it's like a 0.0 and like 19 zeros or something. That's the percentage that one breath is compared to the entire atmosphere, so a minuscule amount. On the other hand, though, if you look at how many molecules, gas molecules, are actually in a liter at room temperature and pressure, it's some gargantuan number. It's like 25 sextillion, which is a 25 with 21 zeros after it. So it's just a huge, like an unfathomably large number. So the question becomes, well, which number is going to win? Like the really tiny number, which is how big a breath is compared to the atmosphere, or the really big number, which is how many molecules are in any single breath. And when you go through all the math, crunch all the numbers and everything, it turns out that they cancel almost exactly, and you end up with, on the average, about one molecule of Caesar breath in every breath that we take.
Fermi estimation is pretty fun if you ask me, because you can come up with answers you have absolutely no business coming up with. Like whether you're sharing air with Caesar. But why him? Why not, I don't know, Joan of Arc or Madame Curie or Tessa Thompson?
He's become, for some reason, like the default person that you hear with this problem. I don't know why someone fixated on, I'm sure back in the days when they were studying classics all the time. But even, 2 to 3 years, the atmosphere has enough turbulence, it mixes enough, where those molecules would have been fairly evenly spread over the entire world. So yes, Shakespeare, Winston Churchill, Amelia Earhart, Confucius, like whoever you want to talk about in history, you have a connection with their breath as well.
But it turns out Caesar's last words provided enough inspiration for a whole book on what the atmosphere is made of.
I think what I was a little surprised about is just the variety of different gases that you do see in the atmosphere. You see refrigerants, you see little bits of anesthesia, you see all the noble gases. I mean, argon is roughly 1% of our atmosphere.
We've treated the atmosphere pretty badly, what with all the climate change and the aforementioned refrigerants poking holes in the ozone layer and all that. Is there any good news?
There's good news coming out about the atmosphere. Things like acid rain we have not eliminated, but it's much less of a concern than it used to be.
Yes, I remember being absolutely terrified of acid rain when I was growing up and learning about it. I don't think I've ever actually witnessed it taking place.
No, but it just sounds so awful, like acid raining down on top of you, yeah.
Oh my god, acid falling out of the sky!
Exactly.
Yeah, it seems like we're pumping less of the bad stuff that creates acid rain into the atmosphere. So even though my elementary school textbooks made me afraid to go outside in so much as a light shower, we've made real progress in that department. It sometimes still happens, and natural habitats damaged by acid rain will need more time to mend, but they are on the mend. But here's an even weirder story from the book, the story of Einstein's lost refrigerator. The tale goes that Einstein, yes, that Einstein, was enjoying his morning cup of joe when he read a tragic story in the paper. Refrigerants at the time could be pretty toxic, and an entire family had perished when their refrigerator sprung a leak. So Einstein called up fellow physicist Leo Szilard and got to work.
They set out to build a better refrigerator, and they tried to make a whole new type of refrigerator, one that didn't use electricity, it didn't have a motor, it was more based on evaporating and cooling gases and mixing different gases in various clever ways to basically, take heat, move it around, do different things.
Unfortunately, the Einstein fridge never took off, because somebody else came along and invented Freon right at the same time. And fridges based on CFCs were a bit cheaper and easier to make than Einstein and Szilard's design. They just also wrecked the ozone layer? Imagine being the chemist who scooped Einstein.
Yeah, there was actually a man named Thomas Midgley. He's kind of well known because he invented not only chlorofluorocarbons, he invented leaded gasoline as well. So unfortunately, two of the worst ideas of the 20th century.
That's a pretty terrible track record. We hope you'll read along with us and everyone at PBS. The Great American Read is a new series on PBS about why we love to read, leading up to a vote on America's favorite novel. Who decides America's favorite novel? Well, that'd be you. Head to pbs.org/greatamericanread to vote on your favorite book. And don't let those other books win. Check out the link in the doobly-doo for more details. Thanks for watching, and don't forget to subscribe, share, and turn on notifications. I could write my own book about how important it is and how much it helps us out. We'll see you next week.